Today, we will focus on the detailed explanation of iPhone 6 Wi-Fi module replacing step by step. Both sides of the logic board are soldered with components dense in arrangement. When it comes to soldering, desoldering of components, we need to be meticulous with operating temperature of hot air gun and heating time applied to avoid bridging or pseudo-soldering of components at high temperature. Some components on the logic board are sealed with black adhesive, for example, Wi-Fi module and NAND flash chip. Some are soldered with no black adhesive. When desoldering components sealed with black adhesive, we need to remove the black adhesive first, so that with the follow-up chip prying process, components around will not be affected. Step 1. Remove black adhesive around the module. Specialized black adhesive scraping knife. Set temperature of the hot air gun at 280 degrees, air gear 7.5. Keep the hot air gun at 20 mm height from the Wi-Fi module. Heat up 4 sides of the Wi-Fi module vertically. Scrap back and forth along 4 sides of the Wi-Fi module to remove black adhesive. Since high temperature might loosen small components nearby, operating temperature of the hot air gun should be lower than 300 degrees. Be careful with the force applied to protect the logic board from scratching. Once done, we can move to chip detaching process. Step 2. Pry up the chip. The knife used to pry up the chip should not be overly sharp at the end, since an overly sharp one might scratch the logic board and chips. Specialized chip prying knife. Set temperature of the hot air gun at 340 degrees, air gear 7.5. Keep the hot air gun at 10 mm to 15 mm height from the Wi-Fi module. Heat up for 15 seconds. When tins soldering the module start to melt, insert the knife between the module and the logic board and pry up the chip carefully with proper force. Tips: don't apply excessive force when prying. Otherwise, bonding pad of the logic board or chip might get levered out. Step 3. Remove tins on the bonding pad. Set temperature of the soldering iron at 400 degrees. Apply mid-temperature tins to the bonding pad. Melting point of original tins decrease with the process. Which is helpful for subsequent removal of tins. Then remove tins on the bonding pad with soldering iron. Step 4. Remove black adhesive on the bonding pad. Sculpture knife used to scrap black adhesive on the bonding pad. Set temperature of the hot air gun at 300 degrees. Air gear 7.5. Heat up the bonding pad. Then scrap black adhesive on the bonding pad. Tips: keep the blade and bonding pad at an angle of 45 degrees. With the scraping edge cleaning to the bonding pad. Scrap back unidirectionally and parallelly to avoid scratching the logic board. Step 5. Remove tins thoroughly. Prepare a length of solder wick. Set temperature of the hot air gun at 320 degrees. Air gear 7.5. Heat up rosin first, then dip some rosin with solder wick. Heat with hot air gun at 20 mm height from the bonding pad. Remove residual tins. Step 6. Clean the bonding pad. Clean the bonding pad with PCB cleaner. Step 7. Apply BGA paste flux. Apply some BGA paste flux to the bonding pad. Tips: don't apply excessive BGA paste flux. The chip might get dislocated once heated. Step 8. Align the new Wi-Fi module. Align the new Wi-Fi module to the right place. Tips: refer to the distance between components around and bonding pad. Put the Wi-Fi module right in the middle of the bonding pad. Do not reverse the direction. Step 9. Solder the module. Set temperature of the hot air gun at 320 degrees. Air gear 7.5. Keep the hot air gun at 50 mm height from the Wi-Fi module. Heat up the Wi-Fi module vertically. With the module sinking and paste flux overflowing, continue heating for 8 seconds. The soldering process will then be finished. Wait for the logic board to cool for 5 minutes. Step 10. Clean thoroughly. Clean thoroughly with PCB cleaner. Wi-Fi module replacing completed successfully.